Imagine this scenario for a second. You are sitting on an absolute gold mine. You've built this massive SaaS platform. Maybe it's a healthcare CRM managing patient records, or, a next-gen fintech app handling millions of dollars in transactions. The stakes are huge.
Yeah, the data is incredibly sensitive, the kind of data that honestly keeps CEOs and compliance officers awake at night.
Exactly. And the traffic is it's exploding. Millions of users are hitting this thing. But here's the magic trick. You have absolutely no servers.
Right, zero.
Zero servers. No racking, no stacking, no patching Windows updates at 3 a.m.
Yep.
It's all entirely serverless. It scales infinitely and effortlessly.
Which, that sounds like an absolute dream for a developer. It's basically utopia.
It is, right up until the auditors show up.
Oh, man. Yeah, and that's where the dream turns into a bit of a nightmare.
Right, because now you have to pass a SOC 2 Type 2 audit. You have to prove to some guy in a suit that you were secure every single second for the last 12 months. But here's the problem. How do you prove security for a computer that existed for 300 milliseconds and then just vanished into thin air?
That is the core conflict right there. It is the tension between the incredible agility of modern serverless architecture, things like AWS Lambda,
right,
and the very rigid evidence-based demands of compliance.
It honestly feels like trying to catch smoke with a butterfly net.
That's a great way to put it, actually. Traditional auditing is designed for things that stay put. Serverless is designed to move.
So that is what we are unpacking in today's deep dive. We have a really fascinating source today. It's a real-world serverless SOC2 playbook. It's basically this battle-tested roadmap from a CRM company that actually pulled this off. They managed to prove compliance for PII and PHI data, really sensitive stuff, in a fully serverless environment on AWS.
And what I really love about this playbook is that it isn't just theory. It forces a complete mindset shift. If you were used to traditional audits, you were looking for physical things.
Right.
You're looking for the server room, the firewall appliance with the blinking lights.
The blinking lights theory of security. If it blinks, it's safe.
Exactly.
Yeah.
But in this deep dive, our mission is to shift that thinking entirely. We're moving away from servers and perimeters and moving toward identity, configuration, and continuous evidence.
Okay, let's get into that mindset shift right away, because the source uses this comparison that really stuck with me. It describes the old way as defending a castle, and the new way is, well, it's remarkably different.
Yeah, it's the castle versus courier analogy. Think about the castle first. In a traditional data center, or even standard cloud computing with virtual machines, you have a defined perimeter.
Right.
You build a firewall around your servers. The auditor comes in and says, show me the wall. Show me the lock on the door.
And if the wall is standing and the lock is engaged, you check the box, you're good to go.
But in serverless, there is no castle. It's event-driven. A piece of code, like a Lambda function, wakes up because someone clicked a button somewhere. Yeah. It runs for, say, half a second to process that data, and then it is gone. It's entirely ephemeral.
So if an auditor asks, hey, show me the server where this specific patient record was processed 3 months ago, you literally can't. It doesn't exist anymore.
Precisely. You cannot secure the perimeter because the perimeter is no longer a network edge. The perimeter is now identity and configuration.
That's a shift.
Huge shift. Security isn't software you install in a box anymore. It is how you have configured the relationships between your services.
That's a heavy concept, though. Configuration is the perimeter. It kind of sounds like we're trying to prove a negative. If the resource is gone, how do I prove it was secure when it actually was there?
That is the million-dollar question. Since you can't inspect the server later, you have to prove that the rules creating that server were secure.
Okay.
You have to prove that the configuration of your identity and access management, your IAM, and your API gateways were set up correctly at that exact moment in time.
So it's less about inspecting the house after it's built and more about inspecting the blueprints and the construction crew every single time a house is built.
That's it. And ensuring you have a camera recording the construction every single time it happens. It shifts the burden from the infrastructure itself to the code that builds the infrastructure.
Which brings us nicely to the foundation of all this.
Oh, yeah.
The who owns what game.
Oh, yes.
The shared responsibility model. I feel like this gets thrown around a lot in cloud circles generally, but in serverless, does the line actually move?
It shifts dramatically. People often think, well, I'm on AWS, they handle the security.
Amazon has guards with guns at the data center, so I'm safe, right?
Right. Amazon does have guards, and they do an amazing job securing the concrete, the hardware, and the physical network.
Yeah.
That is their side of the shared responsibility model.
Okay.
But in serverless, because you don't manage the operating system, the line moves up the stack. You own the data, you own the application logic, and this is the crucial part, you own the configuration of those services.
Okay, help me visualize this. If I leave a digital door unlocked,
If you configure a storage bucket to be public to the whole world, or if you write a Lambda function that allows anyone on the internet to trigger it, that is entirely on you. Amazon ensures the lock works mechanically. You are responsible for actually locking the door.
wow.
The source highlights that misconfiguration is the single biggest risk in this environment.
So Amazon secures the cloud, but you have to secure what is in the cloud.
Exactly. And in serverless, what is in the cloud is mostly just configuration settings.
Let's map this territory a bit then. We aren't just talking abstractly here. The source deals with a specific stack. We have Lambda for compute, S3 and DynamoDB for storage, Cognito for identity, and API gateway as the front door.
Right. And for SOC2 audit, you can't just throw a list of those tools at the auditor and say, hey, we use these. You have to map every single one of those tools to the trust services criteria.
The TSCs, I always forget the full list. There are 5, right?
There are 5. Security, availability, confidentiality, privacy, and processing integrity.
Okay, so you can't just say, we use Lambda.
No, that means nothing to an auditor. You have to say, we use Lambda, and here is how its configuration satisfies the confidentiality criteria regarding patient data.
Got it.
It's about connecting the tool to the rule. You have to build a bridge between the tech stack and the compliance framework.
Okay, so we know who owns what now. Let's talk about actually locking things down. The source breaks this down into what I'm calling the big 3 of operational controls, and the first one is identity.
Identity is the new firewall. We touched on this briefly, but let's go deeper. In a serverless world, IAM identity and access management is absolutely everything. It is the control plane. The golden rule here is least privilege.
Least privilege, it sounds like a parenting strategy. You can only have exactly what you need.
It kind of is.
Yeah.
It means a Lambda function should only be able to touch the exact resources it needs to do its job and absolutely nothing else.
Right.
If a function is designed to read from one specific DynamoDB table, it should not have permission to write to it, and it certainly shouldn't have permission to access your S3 storage buckets.
But here is the trap, right? I know developers. I've been that developer. When you are coding at 2 a.m. and the code keeps failing because of access denied errors,
Oh, yeah.
the temptation is to just break out the big guns.
The dreaded asterisk.
The wild card. Allow action star, resource star. Basically, let this function do anything to everything just so I can get it working and finally go to sleep.
That is the common pitfall the source screams about. It works, sure. The code runs. But you have just created a massive security hole.
How bad are we talking here? Is it really that big of a deal as one little function has extra permissions?
It is catastrophic. Think about it laterally. If an attacker compromises that one function, maybe through a code injection vulnerability dash in a batch, and that function has wildcard permissions, the attacker now has the keys to your entire kingdom. They can delete your databases, steal your S3 files, spin up crypto miners, everything. A SOC2 auditor sees a wildcard permission in a production environment, and that is a massive red flag. It's an immediate fail.
So, no wildcards. Be stingy with permissions. It's annoying to configure up front, but it saves you from complete disaster. That's number 1. Number 2 on the list is encryption.
Encryption everywhere, at rest and in transit.
Oh.
This is completely non-negotiable for sensitive data like PII or PHI.
Seems pretty standard, though. Encrypt your data. Everyone knows that. But the source gets really specific about how you manage the keys.
It does. It talks extensively about AWS KMS, the key management service. It's not enough to just turn encryption on. You have to manage the keys that actually lock the data. Specifically, you need to rotate them.
It's like changing the locks on your house.
Exactly. But imagine if you had to physically call a locksmith to change your front door lock every 90 days. You'd forget. You'd get lazy. Or you'd just lose the new key.
I definitely just leave the key under the mat and hope for the best.
Right. And that's exactly why manual key rotation fails. In this environment, you configure KMS to automatically rotate those keys every year or every 90 days.
Okay.
So even if a key was somehow compromised, it becomes completely useless after a set period. It's automated hygiene. And the auditor loves this because you can show them the setting. look, rotation is enabled.
Simple, verifiable, set and forget. I like it. And then we have the third pillar, the evidence trail.
This is very simple. If it wasn't logged, it didn't happen.
That's the auditor's motto right there.
It is. In a serverless world where the server disappears, the log is the only proof of existence. You need CloudTrail and CloudWatch capturing every single ATI call. Who invoked the function? When? What data did they try to access? Was it denied or allowed?
And these aren't just text files you can edit, right? Like, I can't just go in and delete the line where I accidentally access the CEO's salary info.
Crucial point, no. These logs must be immutable, meaning they cannot be changed once written.
Yeah.
If an auditor thinks you can go in and delete a log entry that shows a security breach, the logs are completely worthless as evidence. You have to configure log integrity validation so that any tampering is immediately detected.
So you're basically building a history book that writes itself in real time, in permanent ink.
That's a perfect segue into the do-or-die factor of this whole deep dive, automation.
Yeah, the source is pretty blunt here. It says you basically cannot manually audit this environment. Why is that? Is it just too much work?
It's not just work, it's the velocity. Think about the sheer scale. A busy SaaS platform might have thousands of changes a day, functions spinning up and down, auto-scaling groups adjusting, database tables being created. The old way of auditing was scrambling 2 weeks before the deadline, taking screenshots of settings and filling out spreadsheets.
Ah, the classic audit fire drill. Everyone hates it. You're running around trying to find out who changed the firewall setting 3 months ago.
And in serverless, that's impossible. You can't take a screenshot of a function that ran last Tuesday. It's gone. You need continuous automation. You need tools that are constantly taking snapshots of your compliance posture.
The source mentions a few specific tools here. AWS Config seems to be the heavy lifter. How does that actually work?
AWS Config is like a security camera for your settings. It continuously records the state of your resources. So whenever a setting changes, say a developer turns off encryption on a bucket, AWS Config records that change.
Okay.
So if an auditor asks, was encryption turned on for this database last Tuesday at 2:00 p.m., AWS Config can say, yes, here's the configuration snapshot from that exact moment.
That is incredibly powerful. It's basically time travel for compliance.
It really is. And then you have Security Hub and Guard Duty. Think of these as the central nervous system. Guard Duty uses machine learning to look for threats. Like if a Lambda function starts communicating with a known malicious IP address or doing something totally out of character.
And I noticed the source material actually mentions some 2025 updates here too.
It does. This is where it gets really interesting. The 2025 updates regarding AI-enhanced threat detection. We're seeing tools that don't just flag a problem, but actually analyze the risk context. And then there is Audit Manager.
That sounded like a total lifesaver in the text.
It really is. Audit Manager maps your AWS evidence directly to the SOC2 controls.
How does that work in practice?
So instead of you manually digging through logs to find proof for Control 3.2 on data retention, the tool automatically pulls the relevant logs and config snapshots and says, here is your evidence for Control 3.2. The source says this reduces manual effort by up to 50%.
That turns the audit from a panic attack into just business as usual, a disciplined operating rhythm, as they call it.
Which is exactly what you want. You want compliance to be boring. If compliance is exciting, you're doing it wrong.
Make compliance boring again. I'd wear that hat. But there is one part that can't be fully automated, and that's the communication gap, translating code to English.
This is a huge friction point. Auditors, generally speaking, do not read JSON. They don't want to read your raw Terraform code. They read English. They need to understand the story of your controls.
So you have to write what the source calls control narratives.
Right. A control narrative is the bridge. You have the policy, which is the intent. We will encrypt all data. Then you have the technical enforcement, which is the code itself. The narrative explains how the code satisfies the intent.
Is there a formula for that? Because I feel like I just stare at a blank page.
There is a formula. It goes control intent, the policy leads to technical enforcement, the config leads to monitoring the alerts, and finally evidence the logs. You just have to write that story down.
Give me an example of that. Let's stick with encryption.
Okay. Your narrative would look like this. We encrypt all patient data at rest. That's the intent. We use AWS KMS with automatic rotation enabled. That's the enforcement. We use AWS config to alert us immediately if encryption is ever disabled. That's the monitoring. And here are the CloudTrail logs proving no unencrypted buckets were created in the audit period. That's the evidence.
That connects the dots beautifully. It makes it undeniable. And looking at the 2025 context again, the source mentions that these policies now have to account for AI.
Yes, this is the new frontier entirely. If you are using services like Amazon Bedrock or Amazon Q generative AI tools, your policies need to reflect that. You need governance on how you are using AI.
So you can't just plug patient data into a public model to summarize it.
Absolutely not. And you need a policy that explicitly forbids that and controls that actually enforce it. The source highlights that policies must now account for generative AI best practices. You can't just ignore the AI elephant in the room.
So your policies have to evolve just as fast as your tech stack does.
Exactly.
Okay, so we've built the architecture, we've automated the evidence, we've written the narratives. Now it's game time, or practice game time, rather. The pre-audit strategy.
The mock audit. This is the dress rehearsal.
Why is this so critical? Can't we just wing it if we have all these automated tools?
You really don't want to find out you have a gap when the real auditor is sitting across the table charging you by the hour. You need to test if you can actually retrieve the evidence you think you have.
Makes sense.
It's one thing to say, we log everything. It's another to say, okay, pull the logs from November 12th for user X, and then realize your retention policy automatically deleted them after 30 days.
Ouch. That would be a complete disaster.
That's a classic evidence after the fact failure. You cannot generate logs for events that happened in the past if you didn't configure the logging beforehand. It's physically impossible. You can't retroactively comply.
The source also warns about drift. That sounds ominous, like a horror movie title.
Drift is the silent killer of compliance.
Yeah.
It happens when you have a perfect infrastructure as code set up. Everything is automated. Everything is in the repository. But then someone, maybe a developer, fixing a bug in a panic, logs into the console manually and changes the setting.
They turn off a firewall rule just to test something and then forget to turn it back on.
Exactly. Now, your production environment has drifted away from your code and your policy. The code says one thing, reality says another. Automated tools like AWS Config are essential here because they can detect drift. They can alert you, hey, someone changed this setting manually. It doesn't match the blueprint.
And tagging was another pitfall mentioned, which honestly sounds boring, just labeling things. But why is it such a big deal?
In serverless, you might have hundreds, maybe thousands of Lambda functions. If you don't tag them like environment production or owner finance team, you have absolutely no idea what you're looking at.
It's like a messy garage.
Worse, it's a messy garage where you don't know which boxes contain toxic waste and which contain old toys. If you don't know who owns the resource or what data classification it holds, you can't prove it's secure.
Right.
An auditor will point to a random function and ask, what does this do? If you say, I don't know, you fail.
So tag your resources, people. It's not just organization, it's literally compliance.
It's the only way to make sense of the chaos.
So we've covered a lot of ground here today. From the mindset shift of castles to couriers to the shared responsibility model, the big three controls identity, encryption, logging, and the automation that makes it all possible.
It is a very comprehensive playbook. It really covers the full life cycle.
When you step back and look at this whole serverless GRC picture, what for our listeners, why go through all this trouble?
The easy answer is to pass the audit. But the real value is much deeper. Mastering this doesn't just get you a certification. It unlocks speed.
Speed. Usually people think compliance slows you down. The Department of No.
That's the old way. But if it's automated, when you have automated compliance, when you know that your guardrails will catch you if you fall, you can innovate without fear. You can deploy code 10 times a day because you know the security checks are running constantly in the background.
It turns compliance from a roadblock into a safety net.
Precisely. It becomes a competitive edge. You can tell your enterprise customers, we are faster and more secure than the competition.
Yep.
That's a very powerful sales pitch.
And I think it's interesting to note, as the expert here, you've mentioned that while serverless removes the infrastructure management, there are no servers to patch, it actually increases the need for discipline.
It does. It removes the heavy lifting of hardware, but it places a massive magnifying glass on your configuration.
Yeah.
You can't be sloppy with your settings. In a way, serverless is less forgiving of sloppiness than traditional servers because everything is code. A single typo in your configuration can expose your entire database.
That is a powerful takeaway. Code is power, but code is also responsibility.
Absolutely.
Before we sign off, I want to leave you, the listener, with a thought to mull over. We are looking at 2025 updates, AI tools like Audit Manager using Amazon Q.
Right.
As we look toward 2026 and beyond, with tools like IAM Access Analyzer and these AI-driven compliance engines. Are we moving toward a world where human auditors are completely obsolete?
It raises a fascinating question. If the evidence is collected by a machine and analyzed by a machine, will the future of auditing essentially be machines checking the homework of other machines?
And where do the humans fit in then?
I think humans will always be needed to define the intent, the why. But the how and the actual check might soon be entirely silicon-based. We might reach a point where audits are continuous in real time rather than an annual event. What if a system could automatically revoke its own certification the second a critical drift occurs, and then reinstate it when the AI remediates the configuration?
A world of self-auditing, self-healing machines. I guess as long as they pass this SOC2, I'm happy.
As long as the data is safe.
Exactly. Well, that's it for this deep dive into the serverless SOC2 playbook. I hope you're feeling a little less intimidated by the audit and a little more inspired to go check your IAM policies.
Please go check your IAM policies. No wildcards.
You heard the expert, no wildcards. Thanks for listening, and we'll catch you on the next deep dive.